Aloha and welcome back. It's my pleasure to introduce to you all Dr. Hanani Kane. She is a scientist, a surfer, a voyager from Kailua, Oahu, who is currently an assistant professor at Arizona State University in the School of Geographic Sciences and Urban Planning. Dr. Kane's research combines geomorphology, paleo-environmental reconstructions, spatial analysis, and the perspectives of a native islander to interpret how islands and their people are impacted by climate changes. Using the ocean as her classroom, the sky as her blackboard, and the islands as models for sustainable living, Dr. Kane has found a unique way to blend observation and traditional knowledge to form a worldview that focuses upon the similarities rather than the differences among Western and Indigenous sciences. She has been a keystone mentor for many of our TCBES graduate students, and I'm so pleased to have her take the mic now to introduce our next speaker.
Aloha mai kākou. It's such a great honor to introduce Kainalu to all of you guys today. Kainalu has been a really important and integral part of my lab, as well as just understanding how our islands up in Papahānaumokuākea will respond to changes in climate. It has been really special to watch Kainalu grow over the past few years as a scientist, as a Kanaka, as well as see him step up into leadership roles and take on so much kuleana as in this role of him as a scientist. But I'm really excited for him to share his project with all of you guys today. So get him, Kainalu.
Mahalo nui haunani for that introduction. Aloha nui mai kākou. My name is Kainalu Steward, and I'm excited to be here and share with you what I've been up to these past 2 years doing my professional internship in this program, where I've had the opportunity to learn different skills and work with solid people that have helped shape me professionally and intellectually. I am humbled and grateful to be presenting this on behalf of my mentors, Dr. Hanani Kane, as well as Dr. John Burns at the Mega Lab, as well as Lisa Canali, the awesome internship program coordinator. The title of my talk today is Beyond Science into Po, Reevaluating the Vulnerability of Lalo in Papahānaumokuākea. You'll notice this title come up again in my presentation, and I hope to convey the broader message of it throughout my talk and really highlight the importance of it within these experiences. Before diving in, I'd like to open up by giving a brief ho'olauna or introduction of myself and where I come from. No laila he pua no wau o nā honua o Pi'ilani, o Maui ku'umokupuni, o lahaina me ka'anapali ku'umamoku, o pu'ukukui ku'umauna, a o mala a me hono kahua ku'umaukai. So I'm a child of the famous bays of Pi'ilani. I come from the island of Maui, where I grew up in areas of Lahaina and Ka'anapali. Pu'ukukui is the mauna that we look up to, and mala and hono kahua are the waters or oceans that have raised me and that I love to play in. So we are who we are because of our community. I'd like to take this time to humbly acknowledge and mahalo the multiple communities from places to people that have been a part of my journey this far. And without any of them, I definitely would not be here today presenting to you all. This olelo no e au or Hawaiian proverb, he lala no wau no ku'umau kumu, can roughly translate to mean I'm a branch of my teachers or trees, Or in other words, I am who I am because of the many sources of inspiration and support throughout these years. There are so many to mahalo, but here are some pictures of those kumu or sources that continue to guide me. From my ohana and hoa, my friends and family, to the mentors I had throughout college, all my kumu at Kahakaulo Ke'elikolani College of Hawaiian Language, the Kipuka Native Hawaiian Student Center, as well as my extended ohana at Hui Ho'ole Maluo and Nakilo Aina, as well as the places that I grew up loving and learning from. I'd like to give a special mahalo to my ohana, Kainalu Steward, who brought me along with her on these many huaka'i and really showed me the value of higher education, the importance of supporting our kaiaulu, our communities, and has supported me in my pursuits of science and Olelo Hawaii. So mahalo, 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 kako for inspiring me to persevere. And so adding to this list of kumu is my mentor that I had the privilege to work with and learn from. Among the many hats that Haunani wears, from being a lead navigator on the Hokule'a, a community leader and educator, she is also an earth scientist who specializes in geomorphology, paleo-environmental reconstructions, and spatial analysis, while blending them with her background as a native Hawaiian. Haunani Kane is currently an assistant professor at Arizona State University in the School of Geographical Sciences and Urban Planning. I'm very fortunate to have her to look up to and the many Indigenous women in STEM that are paving the way. This internship was conducted in collaboration with the Mega Lab at Hilo, which was founded by Dr. John Burns, who has supported me and many other local and Hawaiian students in STEM throughout the years. Before diving into the bulk of my presentation, this is a brief overview of the sections that I will be sharing about. I'll first start off with an introduction, giving you more background information on my project, as well as the place or study site. Then I'll cover the geospatial analysis research of my internship, and then share more about the additional experiences I had in the field and how it connected to my geospatial work, such as using GPS data to correct imagery. Lastly, I will close it off with some concluding remarks. And so introducing my study site, which is located in Papahānaumokuākea, also known as the Northwestern Hawaiian Islands. Papahānaumokuākea Marine National Monument is the largest fully protected conservation area under the US flag and one of the largest marine conservation areas in the world. Although the monument collaborates with other organizations, it is mainly co-managed by these 4 agencies. In addition to the multiple shoals, pinnacles, atolls, and islands, the monument consists of biodiverse communities such as native seabirds, coral, algae, fish, marine mammals, and other flora and fauna. The mission of the monument is to carry out seamless integrated management to ensure ecological integrity and achieve strong, long-term protection and perpetuation of Northwestern Hawaiian Islands ecosystems, native Hawaiian culture, and heritage resources for current and future generations. Because of the high conservation value of Papahānaumokuākea, its unique and diverse biota, and the physical characteristics of the islands, such as it being low-lying, this makes them particularly vulnerable to the impacts of climate change. More importantly, Papahānaumokuākea is a significant and sacred place to us Native Hawaiian people and are revered as kupuna or ancestral islands. Papahānaumokuākea and the main Hawaiian Islands are separated by Kalapolohiwa-Akane, or the Tropic of Cancer, that distinguishes the boundaries between po, or darkness, and ao, light or consciousness. Po is understood to be a spiritual realm where spirits journey upon death and process in the afterlife, while ao is known to be where human civilizations exist. Po is also known as a place of birth and creation, where the Kumulipo or Hawaiian origin story first evolved. Many heiau, or cultural structures and shrines, as well as evidence of society, have been rediscovered today that document the significance of Papahānaumokuākea to our people and their function in these spaces. At the surface level, the name Papahānaumokuākea honors the dualism of Papahānaumoku, who is embodied as Earth Mother, and Wakea, who is embodied as Sky Father. And their joining resulted in the birthing and creation of the Hawaiian archipelago. The name Papahānaumokuākea was actually developed in 2006 during the sanctuary designation process and is credited to the collaboration of the Cultural Working Group, who got together with esteemed kupuna such as Auntie Pua Kanahele and Uncle Buzzy Agard to birth this inoa or place name. Now honing in on my study site, this is a satellite image of the atoll island that my project focused on, known as Lalo or French Frigate Shoals. Lalo is one of the only atolls we have here in Hawaii and is characterized by a crescent-shaped reef platform with an open shallow lagoon and multiple sandy islets. Lalo is known to initially have a total of 16 sandy islets that were lower than 4 meters in elevation, but since the 1900s, 2 islands have been permanently lost and 1 has recovered. This study will hopefully shed light on these fragile atoll systems and why they can be viewed as vulnerable with increasing climate change. Although these vulnerabilities exist, I will share more on how these systems are more so extremely adaptive based on this study. Here's a closer look at Lalo with the dots representing multiple sandy islets. I decided to highlight these specific islets because they were the ones that were mainly identified and mapped consistently throughout the study, but I will be focusing on Terran, East, and the Jin Islands, which are noted with a star. These are some photos of East Island and the Jins as an example of what these sandy islets typically look like with a 360-degree perimeter of exposure to environmental pressures. In Olelo Hawaii or Hawaiian language, Lalo has multiple translations and interpretations that may mean down, downward, low, lower, under, below, depth, west, or leeward. Also interpreted in the name Lalo is a directional pole, also known to be a place where the souls of the gods dwell. Lalo is the most commonly referred name, but other variations of Inoa Aina or place names of Lalo that embody its physical characteristics and relevant mo'olelo or stories include Moku Papapa and Kane Miloha'i. The name Moku Papapa has been historically recorded in chants and can be roughly translated to mean islets with low-lying reefs. The name Kane Miloha'i comes from the mo'olelo of Pele, who is also one of Pele's brothers. It is said that Pele left Kane Miloha'i at Lalo as a guardian during her initial journey to Hawaii from Tahiti. Understanding the meaning of this Inoa Aina gives us better insight into the low-lying characteristics of atoll islands and the way in which these islands evolve in response to climate-related stressors. It also demonstrates how our kupuna, our ancestors, have made these observations long before us and always knew these changes that were happening, that were recorded in its inoa, mo'olelo, and oli, for example, which is why it's important that we perpetuate them. Although there is history and stories within the Western names that are given to these places, it still does no justice in understanding the function and the traits of these places. And by using our traditional names, we also speak life back into the space, which contributes to restoring its function. The sandy islets at Lalo are also really important habitats, especially for our native birds, Hawaiian green sea turtles, and endangered Hawaiian monk seals. These animals rely on the sandy beaches for resting, basking, protection, as well as nesting. Lalo is a central nesting ground for Hawaiian green sea turtles, as nearly 90% of the total population migrate to Lalo for safe nesting. This is another reason for the importance of understanding the future stability of these low-lying habitats. And so what is an atoll and how is it formed? To give you a little background, I included this figure that simply describes it. Atolls form over millions of years, and it starts with a volcanic island. And as the volcanic island erodes from natural causes over time, it begins to subside or sink below the surface, and a coral reef begins to form around the island. As the island gets old enough and completely sinks below the surface, a fossil reef platform is left. While the reef platform begins to erode and grow, then sediment from the reef starts to build and that's how sandy atoll islands are formed. To put this in the perspective of our archipelago chain, Hawaiʻi Island would be a volcanic island that is still active. And as we move up the chain, we have islands that are subsiding or sinking, such as Kauai. And as we move further, we begin to see atoll islands such as those in Papahānaumokuākea. And so for the characteristics of atolls, they are low-lying or less than 3 meters in elevation. They're composed of reef-derived material. And these atolls are relatively young, being formed within the last 2,000 to 5,000 years. Its formation is also linked to changes in sea level over time. And so because of these low-lying characteristics, it makes atoll islands such as Lalo really vulnerable to natural impacts or disasters that are more exacerbated by climate change. For example, that includes wave overwash, sea level rise, and stronger and more frequent hurricanes. On October 4th, 2018, a Category 3 hurricane named Walaka struck Lalo with sustaining winds at 125 miles per hour and waves between 11 to 15 meters in height, nearly wiping out entire islets and affecting the nearby coral reef ecosystems. As you can see in this photo, we see East Island before and after Hurricane Walaka, where it was heavily impacted and how much island loss can occur from just one hurricane event. These photos show how it devastated the surrounding reefs that are also crucial to the stability of the island. Recent research on the health of our reefs at Lalo is also being led by our very own Kylie Pascoe and others within the Mega Lab. So this leads to the focus of my internship project, which looked at evaluating the islands through geospatial techniques and identifying how the islands are recovering or moving between the years of 2018 to 2021. For my project, our research objectives were to 1, evaluate the recovery of islands by calculating the rates of shoreline erosion or loss, or accretion or growth. And then 2, also calculate the change in island area. Another objective is to eventually summarize these findings into a report for resource managers. And so this is a general workflow of the process I went through to conduct this work. First, I collected monthly satellite imagery during a 3-year period from October 2018 to October 2021, using a free online database called Planet Labs, which provided 3-meter resolution imagery. Unfortunately, due to the limitations of quality from the images of Planet Labs, it was difficult to identify accurate results, which I'll further go into later. I also obtained remotely sensed imagery for only East and Terran Islands that were either derived from using a drone or UAS system, or it was derived from digital globe satellite imagery that was provided by federal partners. Then I used the field data, which was a collection of GPS points on site to georeference these remote sensed images. Georeferencing is combining GPS points in real time to an aerial photo so that we have an accurate and consistent location of the shoreline when being compared. I then imported these images to a geospatial program called ArcGIS Pro, where I digitize or trace the shorelines of these different islands, then calculated its total area each month. For my georeferenced imagery, I calculated the uncertainty error based off of these 3 parameters, which I will explain more in detail. And finally, I calculated the rate of shoreline change and island area. To do this, I processed the images and shorelines in another program on ARC desktop called DSAS, or Digital Shoreline Analysis System. DSAS is a geospatial analytical tool that can be used to evaluate past or present shoreline positions or geometry. And so a portion of my project was conducted on site at Lalo, where we conducted RTK GPS data points, or collected RTK GPS data points of the shoreline and island itself. We would take these locational GPS data points and then eventually align them with the imagery to georeference them for East and Terran Island. And here's an image of me and my friend Cami going around the shoreline, logging points with the GPS. To give you a visual of my digitization method and mapping technique, I use the toe of the beach or the low water mark as my guide when digitizing or tracing the shoreline in ArcGIS Pro. The toe can be described by when you first walk into the water and you encounter a dip or a slight drop in elevation. This was a feature that we aimed to map. Previous studies have identified the low water mark as an effective shoreline indicator, as it is less prone to geomorphic changes than other shoreline proxies such as the high water mark and wet dry line. And it is easy to identify in satellite imagery. Previous studies have used the vegetation line as their proxy. However, Lalo has very sparse vegetation. And then this photo on the left is an example of collecting GPS points on the toe so that it can be processed and aligned with our online digitizations. So now moving towards my results. As I mentioned earlier, we needed to account for uncertainty and error for East and Terran Island. We did this by looking at 3 sources of error: digitizing, pixel, and rectification. So digitizing error is a standard deviation of shoreline position from repeated digitization of the same shoreline by the same person. Pixel error measures the spatial resolution or pixel size of the image, and rectification error measures how well the image aligns to the base image. This is important to know, and it gives us an idea of how confident we are in the shoreline's position. So for East, almost a quarter of meter of certainty is accounted for, and about 1 meter of certainty for Terran. Again, this takes into account our ability to identify the shoreline in the same place, the quality of the image, and how well it aligns to the base image. So for quantifying the island recovery and identifying the rate of erosion and accretion or loss and growth, we use DSAS to identify or to assess island recovery 3 different ways. This figure shows how the statistical rate was calculated using DSAS program. And so the NSM, or net shoreline movement, is the distance between the oldest and the youngest shoreline. To achieve the EPR, or the endpoint rate, it takes this NSM and divides it by the time between the oldest and most recent shoreline. And the SCE, or shoreline change envelope, measures the greatest distance between all shorelines. For the following slides, the full methods that I described earlier only apply for East and Terran Island. The dunes could not be georeferenced because the islands move so much, and previous drone surveys do not cover the island area. Because of this, I'll focus on East and Terran. And so these 2 islands are also of special interest for resource managers because they are the largest islands at Lalo. In addition to East being recently devastated, about 50% or half of the turtle population use East for nesting. And so Terran is the next hope for stable habitat. These are just a few reasons why resource managers are paying close attention to these 2 islands. So first, let's look at East. On the left is an image of East before Hurricane Oaʻaka, taken in July of 2018. The image on the right shows the damage caused after Hurricane Oaʻaka. And you can see how much of the island was ripped off its original platform and formed a new island, which is highlighted in orange. Our results indicate that about 95% of the total island was lost from Hurricane Oaʻaka, which is about 33,027 square meters. Again, here's the same image of East prior to Hurricane Oaʻaka on the left. And on the right, you can see what the islands look like from our most recent image in July 2021, highlighted in blue. Our results show that 56% of the island has recovered relative to pre-Oaʻaka values. It also shows that the island recovered or grew about 12 meters per year between October 2018 and June 2021. From these results, we can slowly see the island migrate back to areas of its original reef platform. But between these 2 years, there's a portion of the story missing because we don't see the island morphing from month to month. So I will now show you the movement of east at a monthly rate to give us a better understanding of its recovery. And these shorelines were digitized using the 3-meter resolution planet imagery. The Planet Lab imagery is not used to calculate rates, but to explore how the islands are changing each month, as we are still working out the methods of georeferencing lower quality images. So here we have East Island in 2018 from October to December. This is 2019. And here we see that within the first 6 months, East recovered about 35% to its original size. Here is 2020, and this is 2021. So again, 2018 in red, 2018 in tan, 2020 in dark green, and 2021 in light green. And the dotted layer shows the island before Hurricane Walaka. This shows us that this rollover process is occurring where the shoreline is moving in the direction of the arrows and being eroded and transported to the spit ends and opposite side of the island. And so through that, the island is moving sand from one end towards the southwest, which is pretty cool, and it shows how dynamic East Island is. But another thing to think about is how this process affects other species maybe, such as the biologic communities. So for example, the turtle nests that may be washing away due to this process. And so now let's look at Terran Island. Terran is largely a man-made island that was heavily engineered, where a runway was constructed during World War II. And you can see that in the middle over here. And most of the island is composed of eroded seawalls. And so on the left is Terran from before Hurricane Walaka in May 2018. And notice how much vegetation exists on the island in this image, covering the runway. And then the image on the right is Terran after Hurricane Walaka, which brought waves from the southern direction, heavily affecting this side of the island. For this reason, my results will focus only on this southern shoreline. You can also see in the post-Walaka image how much vegetation was occurred by sediment, or vegetation that was covered by sediment that was thrown up. In addition, this covered a lot of turtle nests and affected their regular nesting habits, such as encountering hardened layers of soil when trying to bury. This also caused the island to grow in elevation by about 0.5 meter, which we found out through digging a shallow trench during our time at Terran last summer. And so after analyzing the southern shoreline, I found that from May 2018 to June 2021, the shoreline eroded approximately 2.8 meters a year, and the maximum distance of erosion that occurred along the shoreline was about 16 meters. And we also hypothesized that the low number of erosion may be linked to the sand that was thrown up on land, and so it actually adjusted in elevation. You can also see in the most recent image on the right of 2021 that the vegetation is slowly returning. And notice this sandy area that we call the spit, which is also dynamically changing. And so now I will quickly show you the movement of Little Gin and Gin throughout the years. So here we have Little Gin and Gin during 2018. 2019, here's 2020, and 2021. And so although these results are not significantly accurate because these islands were not georeferenced and accounted for uncertainty, the main takeaway is to notice how dynamic these islands are and how quickly the shoreline moves in 3 years. And you can see that happening, especially on these sort of spit ends that we call, where the island is really growing back. And so what does this all mean now that we have a better understanding of its shoreline movement after a catastrophic event and looking ahead? Well, as mentioned before, one major outcome of this project will be to provide this information in a report that will be used to, that will be used by resource managers and experts. But if we think more broadly about the different factors that affect the existence of these places, then we can move towards better collaborative stewardship of these places. Asking questions like, how does the current and future health of our reefs affect Lalo, as it is a foundation to supplying these sandy islands? How is the morphology, as described earlier, affect these habitats with increasing changes from climate change? And how do we honor these spaces and its significance as Aina Kupuna and integrate our cultural practices and values? I believe that when these ideas are brought together simultaneously and interchangeably, then we can equip ourselves to better prepare and adapt in the future. I will now transition to share my multiple fieldwork experiences that I had the opportunity to be a part of, and really Papahānaumokuākea, learn by doing. The first is our research cruise to Papahānaumokuākea in the summer of 2021, where we visited the islands of Lalo and Nihoa. This experience was a collaborative effort supported by OHA, the Office of Hawaiian Affairs, Namaka Onauna, and the National Fish and Wildlife Foundation. This experience was particularly special because I got to be a part of the first crew of all Native Hawaiian researchers to carry out this work in the monument under a research permit. This was even more unique because we got to sail on Makani Olu, which is a masted schooner, and envision how our kupuna may have felt voyaging up to these places. Led by Dr. Haunani Kane in collaboration with the Mega Lab and Namaka Onauna, we carried out multiple research projects from looking at shoreline change, opihi habitat, and reef health, and how they're being affected from pressures of climate change. In addition, we were fortunate to have two community members from Kauai join us, Hanalei and Kainoa. And Hanalei, as Aloha mentioned, has familial ties to Nihoa. And so ultimately, this experience helped strengthen our relationship to Papahānaumokuākea, and it felt like visiting Ohana. From this experience, a deliverable I was able to accomplish was creating an ARC story map of our trip, describing it in more detail. I titled it Beyond Science into Po because I wanted readers to know that this research cruise was beyond science and conducting research for us. But as I said earlier, it was going up there to learn from these places and grow relationships within it. I was able to enter this story map in a global National Geographic competition where I was chosen as a finalist. Although I did not place in the top 3, I was still humbled to share stories with others around the world. And so this is a screenshot of one of my favorite quotes from Haunani that resonated deeply with me. And this is the link if you folks would like to check it out. And like Aloha was saying, I see these ArcGIS programs, especially story maps, as another tool we can use to share mo'olelo or stories about our places. Another great opportunity that I accomplished during my internship was being able to go on board the EV Nautilus as an ocean science intern to conduct deep sea research at seamounts within the monument to assess their geologic and biologic communities. In this paid position, I assisted lead scientists by logging data, such as observations on our dives, and helping out with processing the samples. And this behind here is what we call the rover, or the ROVE, a remotely operated vehicle. That was basically our eyes and hands that would dive deep down to these seamounts. And that's how we would make these observations or collect samples. And so the science was really cool, but one of my highlights was being able to share our work with Kula Kaiapuni, or Hawaiian immersion students back home, through live ship-to-shore interactions. This was mainly led by Holden Kalamaehu Takahashi, who is the Olelo Hawaiʻi liaison on board. I would also like to shout out the work of my whole Kim Kanoi'ula Morishige, who works with NOAA, and for her efforts in making these interactions with our communities possible. It meant a lot to us to share experience and science through our Olelo Makuahine and show these kids that Olelo Hawaiʻi is relevant, alive, and so important in whatever career they choose to go in. If you folks want to learn more about these interactions, there is a video on YouTube called Building Pilina to Deep Sea of Papahānaumokuākea. And so lastly, in between these experiences, I got to lu'ui kahana, or just dive into it and practice doing geospatial fieldwork at different sites or parts of Hawaiʻi Island, including Kalaimanoa in Ka'upulehu and Laihala in Keaukaha, to eventually map these coastlines and how they will be impacted from sea level rise. Through this work, I also became drone certified and obtained my license to continue practicing and growing in this field. I went from knowing very little to nothing at all, using any of these geospatial programs or tools in the beginning, to now being more confident and gaining new interest in how I can use these modern tools to better understand and protect our coastlines and communities from climate impacts. With that said, I am humbly honored to share that I'll be transitioning to Arizona State University to pursue my PhD in the geography program, continuing to work, learn, and be inspired along Dr. Haunani here in Hilo, Hawaii. And finally, in conclusion, I'd like to leave you folks with this quote by Papa Mau that says, "If I have courage, it is because I believe in the knowledge of my ancestors." This quote has always inspired and resonated with me since I first read it, but especially in this field of science. Although I struggled with identifying myself as a scientist through the years, these words have always reminded me that my kupuna were scientists and one of the best at it in their everyday practices and lifestyles. And so I hope those who may have similar doubts to remember your kupuna and the sacrifices that helped you get to where you are today. And so with that, I would just like to say a big mahalo nui to everybody for tuning in, and all my various support systems, especially my mentors and Lisa Canali for helping me complete this internship. Mahalo nui to my cohort for always supporting one another. And a big mahalo to my ho'opili, Aloha and Lauren, and the entire kopono, Ohana, Hale, for all your kako'o since day one. Mahalo to our funders and supporters of this project, including NOAA, National Fish and Wildlife, OHA, Namaka Onauna, the Mega Lab, ASU, as well as UH and the TCBES program. So yeah, with that, I'd just like to say mahalo nui, and if I'll take any nino or questions. Sorry, Lisa, I can't hear you. I don't know if you guys can hear me.
Okay, I'm so sorry. I was just applauding you and speaking your wonders. My apologies for having my mic off. So we're going to open the floor. Yeah, we're going to open the floor for questions. And Dr. Ostertag, please go ahead and unmute yourself and ask the first question.
Thanks, Kainalu. That was really great to hear all the work that you've done. I was just wondering your first example where you showed the changes over time and the recovery, that just is the sand that's deposited, right? Not like the recovery of the vegetation, or it's just getting the original substrate there. Is that right?
Yeah, correct. So it was just showing I guess just that process between those 2 years of the sediment coming back. But for Terran, for Terran Island, you do notice some vegetation also recovering over time. But for like East and the Jins, because yeah, the really sandy environment, there's not a lot of vegetation that grows on them. But yeah, it's still in the process of recovering because as I showed it, that was like a year ago. So it would be cool to see, yeah, how much it has recovered since.
Well, I have a feeling you'll get back there at some point.
Mahalo for that question.
All right, thank you. And who else would like to ask a question? All right, go right ahead, Celia.
Nalu, that is Kainalu. That was so wonderful. I did not see your scientific work before, so I really appreciated the comprehensive viewpoint of you as a student, and so congratulations on this work you've done. My question is about this idea of building Palina, and especially with these lands that you are so closely connected to, and integrating your scientific observations in building Palina. So I'm wondering how you felt with this deep connection with the ancestors, with the lineage, the learning about the history and the place from the lineal descendants of these places. How did that help integrate with your scientific Hilo, right? How did that, in what ways do you think that if you can give a specific example, and maybe when you were talking to the students, when you were teaching the students, if any, maybe some of that kind of relationship of Hilo and manifested with scientific observation.
Yeah, mahalo nui Celia for that amazing question. And yeah, like we talk a lot in your class, Pilina is so important in the work that we do, because us people are not separate from our landscape, and we can't understand a place if we're not actively out there engaging with it. And these tools that we have with science is only one way to understand it, but to understand it in a relationship where you feel the waters, or you feed from that place, or you interact with people that have stories and connections for generations, and it enhances your work way much more. And so I really want to shout out to one of my first internship projects, where I worked with Kamala Anthony down at Waiuli in Keaukaha, as well as Shri Kauahi. And that was my first really research experience, and that was kind of where I really saw how the efforts of restoring local i'a while including or practicing science and looking at our place names and stories can enhance our work that we do as science. And so, for example, through that project, I was able to find that about the amount of water in an Olympic-sized swimming pool was flowing out along that coast into that fish pond. And the name of that area is called Waiuli, which is Vai being fresh water and Uli being this deep, dark blue. And how all that runs all the way past into the deep end. And so just awesome how our science can prove, or not prove, but support what our kupuna already knew. That's, as I mentioned, is recorded in these names, in these stories, and in our language. And so I think, knowing our language is so important, because that's really the data that's there in front of us if we know and we actively seek out for it. So I hope that answered your question a little bit, but mahalo nui.
All right.
Aloha Kainalu. I have a question real quick.
Aloha malu.
I should turn on my camera. So you just mentioned about science, or Western science, supporting our ike kupuna and our traditions of our kupuna as Kanaka Hawaiʻi. Throughout your process of this project, were there ever times where the processes or the view of the processes were flipped, where you had to do research in finding ike kupuna to support scientific findings and scientific research throughout your internship there? And were there any challenges looking for that piece of resource or ancestral knowledge to support what you are presenting scientifically?
Yeah, that's a great question. I think for me, I'm always interested in knowing more, I guess, on the cultural side and what our stories are is out there. But I guess one example is when researching these places, these islets, as you notice, a lot of them have Western or English names, and so we haven't really found actually particular names for each individual island, because Lalo is just the place itself. And so I guess another kind of goal for us during our trip was to go up there and you know, see these places and maybe be inspired that based off of our experience and our observations to come up with a name or bring Mana'o maybe to the cultural working group who can help guide us in that. And naming and giving these places, you know, Hawaiʻi. But yeah, that's just one example. So mahalo nui for that question.
Oh, mahalo yaʻoi. That's a sick, sounds like a sick process to be a part of, renaming or reclaiming Hawaiian names to Hawaiian spaces. Mahalo yaʻoi, nui ka ha'aheo, and hulo ho'omaikai.
Mahalo.
All right, excuse me, we'll take one more question. So Whitney, when you get a chance, please unmute yourself.
Yeah, I just had one quick question. Just as we're going forward, each in our own paths of research and conservation, and just like knowing how important indigenous knowledge systems are, how do you think we can better support and incorporate indigenous practices into our conservation and management practices and research?
Yeah, that's a great question. And I think that's one a lot of people are asking nowadays. And I think it starts with you doing your work and seeking out the people that know these places, and maybe even making space for those people to also work with you. And I think it really depends on the person conducting the work and how far they're willing to go, I guess. But yeah, I guess that's a short-winded answer, but but yeah, seek the right people and build those pilina, those connections over time.
Great, mahalo, thank you, and great job.
All right, thank you, Kainalu, and thank you everybody for being here this morning. We're now going to take